Okay, so today in class I gave a little lecture about the idea of a field or a field condition. We looked at some examples on how to make field drawings and diagrams and what that might mean for architectural responses. If you wanted to read more about fields, you should look up Stan Allen's From Object to Field. This link up here is a PDF copy that's on the web. The second part is if you wanted to download this Grasshopper definition, which has several subcomponents in it, you can get it at this link. There's a lot of kind of complexities, and it was something I was testing out as I built it. In class, we kind of built it piece by piece, but I'll today just walk you through in the video what each thing is doing. You can download the definition at that link right there. The first one we were looking at was the geometric transformations. So this is something where in the definition we end up making a polygon, and the polygon's number of sides changed based on its relationship to either a curve or a point. And also the size of the polygon changes based on its relationship to a point. To do that, we started with a rectangular grid. Preview that. And you can see it's there. In this example, I was actually creating a series which was put into a z-vector to move the grid, let's see, I'll get the perspective, up until 3D. We didn't cover this in class, it was just another kind of test I was looking at. So let's see. What we're going to do is going to set a point. I don't actually have one right now. So now if I didn't take one, so we'll do it this way. If I put a point in here, that's not it. Oh, it's not previewed, that's why. I'll delete this one. So my point is there. I can have the gumball on it. To get that, I go to display, gumballs. You can also put a point in, a rhino point into Grasshopper. The other thing I was doing in this example was using a curve. So do that. And I'll set that curve here. So it's populating right now in three-dimensional space up on those axes. I'm going to change it so it's just flat here in a second. Maybe should have done that prior to putting in the curve, because now we're going to get lots of stuff worked out. So what I did is I actually just disconnected all the move geometry. We just want the points from the rectangular grid. So we're measuring the points to the curve, we're measuring the points to this point, and later in the polygon we're using those points. So as I go through this, we have the curve, and we found the closest points, the curve closest points. That's curve closest. Using this component, we're actually finding the distance between the curve and any of the points created on the grid. We did this a few times. We'll look at this example. Go ahead and just delete this. We're not moving it anywhere. Here we're looking at this point and measuring the distance from all of the points to that point. We make that distance the denominator of this division, so we're taking 15 and dividing it by all our distances, and then we're using a minimum and a maximum to set the size of the polygon. So if I go ahead and just preview this polygon, you can see that here I'm going to unpreview the grid and unpreview the closest points. Actually just clicked reverse by accident. T is reversed, but we're not using T, so it doesn't matter. So here you can see the size of our polygon is based on the location of this point, and the number of sides is based on the curve. So as it's closer to the curve, it's a circle, and as it moves further away, it becomes a triangle with squares, octagons, pentagons, and hexagons in the middle. We stopped right there because in the other examples we looked at color. All of this stuff is covered in the next example. So you don't really have to worry about that portion of it if you're just working with geometry. If you wanted, at the end of the polygon we have all these polylines. Those could really be passed right into a boundary surface, and the surface can be turned on if you wanted to shade everything in. From there you can use the next section, which is down that way, to color these things in different ways. So let's jump to that one now. just go ahead and select all this and unpreview. The next one, what we did is we used a hexagonal grid. So if you just type grid, it doesn't work actually. Hexagonal. This is a hexagonal grid, and under vectors, it's under grids. You can use all these different types of grids. We have sliders in here that control the size, the number of x, and the number of y. And just like before, we're going to take a point, preview this one, that's the point right there, I'll zoom in on it, and we're measuring the distance between all of the points on the hexagonal grid to that point. Just like before, we're making that the denominator of division. We're setting a minimum and a maximum. Remember, your maximum value always has to be smaller than your minimum value as we're passing it through. And then in this example, we create a circle. In class, we were looking at scaling the hexagrid, which you can see there's the hexagrid, and then we're making a circle based on the points and the size transformation here. So the radius of the circle is changed by the distance. So I'll continue with this one. I'm going to turn off the hexagrid. So here we just have circles. And then we talked for a moment about how when we use color data, it has to be between 0 and 255. So if I turn on preview for these points, we're going to set these. In class, we were smart about it, and we actually named them. This was our red, our G, green, and this is our blue point, blue. Let's see if I can delete the group there. I deleted the little group box on this just to make it a little easier. I also mentioned in class that sometimes it's nice to make a circle around those points. It makes it easier to find them. So here's our red point, and I can slide this around. Here's our green point. I can slide that around. Just like before, sometimes you have to actually make a point here and then use the point command here to set a point, a physical point. If you're on the latest version of Grasshopper, you can just use the gumball, which is kind of convenient. Then what we did is we said, all right, well, in those circles, find me the distance between my red point and that circle. This is actually smart enough to know that we're going to be using the center of the circle. For our polygon example, that didn't work. So we had to find the area of, let's take the area of our circles and use the centroid as the distance that we're measuring between our red point and the centroid, between our red point and the blue point, between the red point and the green point, vice versa, green and blue. So this is doing the exact same thing for me. Hide that stuff. So these distances come out, and they're all kinds of numbers. And if I double click and type panel, I can look at those. So these panels here, I have lots of different distances. I can pan down. I get a whole bunch of them. What I do is I use the bounds command, B-O-N-D-S, bounds, and I flatten that. To flatten something, all you have to do is click its input or even its output. For us, we're clicking the input, and we're going to say flatten. So let's look at the two examples. Right now this is flattened. It says, well, in all of your distances you have 0.086 all the way up to 16. But if I didn't flatten it, it's going to look at every set a little differently. So we have different bounds for each set. We don't really want to work with that. So when we flatten it, it just collapses the list and gives us something we can work with. And then we use the value remap. So if I say remap numbers, what that lets me do is take all of my distances, which I plug into the V, and my bounds, the new domain is from 0.086 to 16. That's my starting domain. And I wanted to give it a new domain to map it into. So while these things right now are evenly distributed among 0.06 or 0.086 to 16, I want to stretch that same thing up to 255. To do that, I type domain, and I'm going to use the construct domain, not domain squared. That's for 2Ds. These are just one-dimensional domains. And I use the slider, just number slider. I'm sorry, we didn't use slider. We used digital scroller, just because it looks different and is new. I can still double-click on this and type 0. Can copy and paste it and type 255. I can put any number in here. But I use those and plugged them into this domain component so that A and B is set. So tell my remap, remap these distances with this starting domain to this new domain. So when I look at my values out of this side, they're kind of scattered about in from 0 to 255. So I plug those into, I'm not looking at that one. We plugged them into an RGB component, and to get it, we talked about how it's the British spelling, color, and we're going to use color RGB. I also put a slider in for the alpha, which is its transparency. So we copied and pasted this group. We didn't need that one. We copied and pasted this group 3 times, and we hooked it up to our green and our blue here and here. We don't need that. This was another little example if you wanted to look at how I added these values together and then again remap them and then use them as something that would just give black and white. So basically this is adding all the values together, taking a min-max and saying, well, things closest to these dots become white, things furthest away become black. We had a better example than that in class where we used the RGB and we said, well, here's our red values, here's our blue values, here's our green values, here's our alpha. That color then goes into a custom preview here. So we're taking our boundary surfaces and we're going to take our color, and what that gives us is this diagram here where we have kind of subtle color shifts, and if we came back to where our colors are, I can move these around and we change all the shading of the object here. Slide blue over. And so we also talked about how I can control the rate of change. If putting these things in close position together, obviously the gradient between them is going to be much faster, where right now the red and the blue are far apart. So here we have red, there we have blue, we have purple for a while, and then it transfers. That was how we were dealing with color. Take all that, right click, preview off. This final one for me was kind of the most fun, and it was looking at the way under vectors we can work with fields. And then these are kind of magnetic fields or electromagnetic fields, not to be confused with the concept of the architectural field, although I feel they can be very closely related. So what we did is we started with the point charge. I'm just going to set a point here, and if I preview this, we talked about how this is pushing away because it's a positive charge. If I put in a curve, sorry, it has to be a line, so I'll put in a line here, set one curve. Now if I look at my line charge, it's marked there, and this is a negative charge. Let's see how else this. I need to put in also a spin, so I'll set a point there, and I'll look at our spin charge, which is really, really big in this example. So I'm going to turn down the radius, and then I can control the strength. You can see the arrows flip direction. Here it's positive, there it's negative, but it doesn't really show you how big they become. So let's go negative here. The other thing I had to do is do a rectangle to control all of this stuff. These lines will get bigger and bigger and bigger. So if I take a curve, right click, set one curve, and use this curve, I can make it a boundary surface, which we've just used in the last example. And then I'm going to use divide surface here to divide this thing up into a series of points. And we're using those points to evaluate the field. So we take our curve, our point, and our spin, and we had to merge them. So we can use merge fields here, and I put in my line, I put in my point, and holding shift you can just add more and more things. Now these are all merged into the same thing. So we're evaluating, so that's the last thing we did here, is under field, we said give me a field line. We plugged our field in, and we plugged all the points from our subdivided surfaces as a place to evaluate. So preview that, and I can hide all this stuff. So now we just have let's turn these points back on, preview them, and this way I can go in and kind of manipulate this. Well, I hope I can at least preview that point. And with this curve previewed, I can go in and just hit F10. I always forget that when I hit F10, it stops my recording software. So I'm going to click this line and type points on, and then I'll be able to use kind of these controls to change the way this thing's lining up. Let's see if we get something that just looks nice. All right, that's something. I'm going to take this point, get some cool stuff going on. And for our spin force, let's look at here. Let's see at the radius. So these are flat. Remember in class, at the end of class, I showed you can actually pull these things up and they'll begin to move in the z dimension. The last thing I'm going to do is something we didn't do in class. In each of these fields, I can put a boundary on. We know that our curve, the rectangle on the outside, is what's bounding everything. So I'm going to plug that in and just say that everything has to behave inside of that curve. So you can see it stops there. So I can keep playing with this and moving things around. I can change this from negative to a positive charge if I wanted to do something a little different. I can control its size. There. I'm going to go with something like that. I think it looks pretty good. You know what? Let's see. I'm going to change this. So the slider is all the way down to 0. If I right click it and go to values, I can change this to -15. Enter. Okay. And now if I bring it down, then we get kind of two diverse things. We get this kind of implicit line that's not there. I'm going to take that. Apparently we're having problems. Maybe it's with the boundary. Some lines cannot be solved, which might be why we're getting some of these jagged things. I'm also going to increase my count here to 12. It'll only go to 10. Change the slider value maximum to 20, so 25. So now we got a lot of lines. What we did then is take our field lines. This one is having an error, but I'm going to still work with it. We asked to get the lengths by just asking length. The length of the line, then, like we had done before, we took the bounds here, and we had to flatten them. So right-clicking, we flatten the bounds. That's that part. We plug our length in, and then we had to deconstruct the domain. So deconstruct domain squared, deconstruct domain here. So what this does is, if I pull open a panel, you can see we have a whole bunch of lengths. We take the bounds, so the flattened bounds, and then by plugging that into the domain here, we can separate the start bound from the end bound. Plug them into a gradient. Use this gradient here. So we have our start and our end, and we're evaluating all the lengths within that. By right-clicking, we can change the preset, and by double-clicking, you can change the color to anything you want. Let's say the thing I don't really get with this is you actually define two colors. I don't know why. It's like the color on this side and the color on that side. It's a little confusing. So let's just take that and that. We're taking all our lengths, and then again we're using a custom preview. What are we previewing? It says what geometry. We're previewing our flow lines. We're using this gradient. So if I preview this and hide all of that, I'm going to hide this stuff back here too. Preview off. You can see that the longest lines are red and purple. The shorter lines are kind of that blue color. The final step that we wanted to look at was how to bake these attributes. And there's a little script that was downloaded. Let's see if the author of it, yeah. If you want more really great Grasshopper stuff, look this guy up. It's pretty good. We need to keep the controls here to be false at all times. And then all we really need is this C# component. So I'm going to copy and paste this stuff. It stays connected to everything. So I'm going to right-click object and say disconnect. Right-click name, disconnect. Right-click layer. Everything gets disconnected except for activate. These are all going little components that go into the script. So if I take all of this stuff to the end, to my field lines example, what I can do is say, all right, well, take my field lines, which are my object, goes into object. Take my gradient and make that the color and the material. We can try to see if we type panel. In here I just say curves. That'll be my layer. And I'm also going to plug it into name just to see. So now I'm going to make sure that here I have curves is a layer it can actually bake into. Open back up Grasshopper. And I just have to click this Boolean toggle. Right now it says false. It's not going to bake with attributes. Click it, it says true. It's baked with attributes. Click it again, it's false. Now if I close Grasshopper, let's see if they're on the right layer. They are. So now all those lines are baked. Some of them look really messy, really weird. But now I can take all of them and export them to Adobe Illustrator. And that works for any of the examples we looked at today, this system. So if you wanted to do your color data, which ended up being this one here, let's take all this stuff and scale it. Let's do that. Let's do this just for see how it ends up looking. So all of this stuff, we'll take it over here. Let's take this panel, copy and paste this panel, we'll bring it down. And we'll call this circles. That'll be our new layer. Circles, there we go. So this is going to be our layer and our name. Our objects are our boundary surfaces here, which are getting colored. And our color is our RGB alpha, so that's our material, and that's our color. So now everything's plugged in here. False becomes true. Click it again to go back to false. Close this. Type grid in Grasshopper, and H hides the grid points. So here, I have, let's look at it in top view. Here I have kind of the line work over top of the transformations. Maybe they're a little heavy or a little weak, but this is where I can start to combine these different techniques and start kind of using it to diagram conditions. I think the most important thing I want everyone to remember is that you're controlling portions of this information, you're not controlling all of the information. And so it's for us as the designers to come back in to kind of sometimes what can be very seductive diagrams and figure out what they mean and how we want to use them. And by all means, if you need to change something that it's not what you want, once you bake it, you can start doing that. So that was just a scale 1D, and then I'll say I'll stretch this part back out. If that's what I want, if this makes the most sense for my project, then I don't need Grasshopper to tell me something, that's kind of irrelevant. I'm still the one that's in control. If I wanted to come in and say, well, I want a void here, well, I can just delete everything. I don't need it. But at the same time, I have opportunities to say like, well, maybe there's a kind of density here that gets passed through. There's a cluster here, and there's kind of some break along this face. So if I want, I can take all this stuff and in 3D even move it. I don't want to look at the boundary. And so now I've really started to kind of transform the diagram into something